Hi everyone, let's take a look at the following physics kinematics example. Number 10, a lovesick gnat wants to throw a bag of candy and love notes into the open window of his girlfriend's bedroom 10 meters above. Assuming it just reaches the window, he throws the love gifts at 60 degrees to the ground. Part A, at what velocity should she throw the bag? And part B, how far from the house is he standing when he throws the bag? So the two unknowns you're looking for. So the first step is I'm going to draw a diagram, and it looks roughly speaking something like this. There's going to be a window up here, and I'm just going to write this so it's clear. And you throw this in such a way that it makes it just to the window, not above, not below, but at the window. Now, the angle that we're thinking about is exactly 60 degrees. So if I draw an arrow to demonstrate what we're looking for, you can break this into components. So what you'll be looking for is v, which is the velocity. So again, let's highlight this. It goes to find the velocity, which we define as v. And again, notice I'm giving you the most important section. I'm not writing down the given, the require, the statement. I'm going straight to how to analyze this and what is the actual solution. So if you look at the initial horizontal component, this is going to be v cosine 60 degrees. And if I look at Vy or Viy, the initial velocity, the vertical component, that's going to be V sine 60 degrees. So again, that's the component I'm talking about. Now, this is 90 degrees. The first step is I can write down one of the 5 kinematic equations. Specifically, I'm thinking about Vf square equals to Vi square plus 2AD. And of course, in this case, I am thinking about the vertical component. So I'm going to put a y subscript just like that. So now I go back and I think about what's given to me. What is the final vertical velocity? Well, it's going to be exactly 0 because for this to make it, it basically means that's going to be the maximum height. And at the maximum height, the velocity is going to be 0. If I think about VIY, that's basically V sine 60, which I'll put in brackets, to the power of 2, plus 2 times AY is the acceleration due to gravity, and it's always negative 9.8. And of course, notice I'm not putting the units here. You could write down negative 9.8 meters per second squared if you like, but this is good enough. And delta dy is going to be 10 meters. And again, notice it's positive 10 meters or positive 10 because relative to the object, this is above, right? So the object started here and you're looking at 10 meters above. So delta dy is positive 10 meters. Now from here, we can solve for v. And again, you can use the calculator. You can do a little bit of mental math. It's really up to you. So what I can do is I can take 2 times negative 9.8 times 10, and I can bring it to the other side. So that's going to be 196. And that equals to v squared times sine 60 quantity square. And of course, I can divide both sides by sine of 60 degrees square, just like that. Cross that out. The opposite of squaring something is to find the square root. So I will use the calculator for you just to demonstrate that. I take 196 divided by sine of 60 square, then I take the square root. And this works out to be 16.1658074 meters per second. And of course, if I round this to 1 decimal place, this will give me 16.2 meters per second. And technically, since they're asking for velocity, I can even put the arrow back and write down 60 degrees to the ground. So 60 degrees to the ground. I'll put this in square brackets for you. And we can match the answer in a second. So to the ground. Put a box around this. And of course, this is exactly the same answer as the answer key, just like that. Now, in the second part, it says, how far from the house is he standing when he throws the bag. So you're looking for delta dx in this case. And again, I'm just going to show you one approach. If there's a faster approach, feel free to comment below, and we'll take it from there. Now, to find the horizontal displacement, I would say you need to know time. So I would go back to find the time of flight. And once I solve the time of flight, I can plug it back in to find the horizontal displacement. So again, I'm going to go back to D equals to VIT plus half AT squared. So my goal is to find the time of flight. And again, specifically, I'm thinking about the Y component just like that. Now, the major difference now is I have some of the answers. So for example, dy, that's going to be 10 meters. Again, it's positive 10 because it's above the object. VIY is going to be V sine 60, which is 16.2. So I'm taking that as the approximation. Sine 60 times time plus half times. Again, AY is the acceleration due to gravity, which is always negative 9.8 times t squared. Now, we're going to apply the quadratic formula in a moment. So again, what I'm going to do is I'm going to equate this to 0. I'm going to bring everything to the left-hand side. Half times negative 9.8 is going to be negative 4.9 times t squared. I'll bring it to the left. That's positive 4.9 t squared. Minus, again, if I take the calculator and I work out 16.2 times sine of 60, again, it's roughly speaking 14.02961154. I'm just going to round this to 14.0. Again, it's not going to be exactly the same answer as the back or the answer key, but it will be very close because I'm rounding it as I'm solving it. Now, what I can do is I can go straight to the quadratic formula, negative b, so negative 14 plus or minus the square root of negative b squared minus 4 times a times c divided by 2 times a, just like that. Now, there are two answers, but the only answer I'm expecting is going to be one of them. So again, I grab the calculator, I'm working it out, and here's one possible answer. So I'm just taking the numbers inside the square root. That happens to be exactly 0. So 14 divided by 9.8. So one answer that I see is going to be 1.4. 1.4 28571429. So I realized this right here is going to be 0. So that makes me think that I could have maybe factored this as a perfect square. But anyways, that's one of the answers. So if I go back now and I think about the kinematic equation, D equals to V1T plus half AT squared. Again, now I'm thinking about the horizontal component, and that's exactly what I'm looking for. I'll draw a line to divide these two different thoughts. Again, AX in the world of kinematics, under projectile motion, it's always going to be 0. Again, dx equals to 1.4. Let's write down a couple more decimals this time. Let's say 1.4286. That's the time. I kind of swapped it. And I should not write V1, I should write VIX. That is V, which is 16.2 cosine 60. So again, just to make sure everyone's clear with this, time, I wrote it first. And VIX, I wrote second. But again, when you multiply, order doesn't matter because of the commutative law. Anyways, I'm going to take the calculator. I'm going to work it out. So 1.4286 times 16.2 times cosine 60, that's going to be approximately 11.57166 meters. And if I round this, let me look at the answer key here. That's 11.5. Okay, so I have 11.6, so it's off by 1 meter, but that's because I did use the rounded figures. But again, the horizontal displacement is 11.6 meters, which is exactly or almost exactly the same as the answer key. If you find this physics example meaningful, this video is adding value to your course, please comment, like, share, and subscribe. I hope this makes sense.